My name is Tim Mashford, from a very similar area of Victoria Police. We're Specialist Intelligence Services Division. It's a new division. And I run our mapping unit, or our geospatial analysis unit there, which is currently called the Intelligence Mapping and Analysis Unit, and we used to be called the Geospatial Analysis Unit, and I think we're going to go back to that name soon. So, just a bit of background. Don't write this down, pretty boring, but just I studied mapping basically at uni, mainly at RMIT, it's itchy. Then I went to University of Tasmania, worked at DSE as my first job, Melbourne 2030 growth areas, so planning for Melbourne's growth over the next 30 years at the time. It was a lot of work, and it's good to see that now they've just ignored all those boundaries and they build wherever they want. And been working at VicPol for a while, since 2004. So I started off as an intelligence analyst there, and I now run that small unit we've got there. From time to time, I've done some work for Charles Sturt Uni on their crime mapping subject, which is now called Imagery and Geo-Spatial Intelligence. I don't know what the hyphen's for. And the one thing I will suggest you write down is what I did in 2009 was called Australian Youth Ambassadors for Development Program. It's an AusAid program for anyone 30 and under. Sorry, Craig, you can't go. It's a really good program though. They fund you for about a year to go off and do a placement in a developing country, mostly in Asia or the Pacific. And a good way to look at it is, a bit of a year-long paid holiday. You do some work there. I didn't do much work at the Vietnamese Institute of Geography. I had a very fun year there. And now I'm back at RMIT doing a grad dip in statistics. So for those of you learning statistics, I feel your pain. It's fun. Yeah, it's all right. So a little bit about GIS, in case you don't know, Geographic Information Systems, what the sort of the mapping software are generally known as. And I'll go a bit into this. I don't think Swinburne has a GIS or geospatial department, or whether you get a chance to do any of those subjects. So my unit has 4 of us there, unsworn, so non-police members, and we're all GIS specialists. We've all been to uni in that area. There's another area which was traditionally staffed by sworn members, so there was always a bit of an issue where they weren't really specialists in that area. We've been going through a bit of a review where it looks like they're going to sort of merge our areas. The main users of mapping in Victoria Police are intelligence officers or analysts. So there's about 700 installations of the mapping software we use called MapInfo. And the way it's used varies a lot. Some people just use really basic mapping, points on the map, basically a glorified version of their pin maps that they used to use. But a lot of them are now using that for analysis to actually say what's going on here, why is it happening, when's it happening, things like that. Some of our specialised areas use a lot of mobile devices, so search and rescue and water police, there's no addresses out on the bay, so they need to take some device out to capture the location of where those offences are occurring. And traffic started to use it a lot as well. I'll skip through this quickly, but just what we do is basically geospatial analysis, anything to do with where stuff is, changes over time, whether the stuff sort of moves over time. We'll do sort of map of events for prosecution to go to court. Not too fond of those because sometimes we get called up and have to go to court and have some murderer sitting there staring at you or something. Not too nice.
What are you pointing at me?
Well, I don't know. It reminds me of something. Geographic profiling I'll talk about, sort of the analysis of the geography of a crime series. That's sort of probably the most fun stuff we get to do. A lot of general maps were done, especially during the bushfire season. And we do a lot of programming and stuff, so create tools for people to use and run training courses there as well. That's an example of the typical sort of crime maps that are produced a lot. I think fake data. Everything I'll show you today is pretty much fake data, so don't worry if you live here, you're not going to get it hit on the way home. On a burglary, so. And we do a lot of temporal analysis too, of when stuff's happening, so being able to visualise that is a bit of a challenge as well. With this, for quite a few years, this is sort of all the Victoria Police analysts would produce, would be a map and say, there's my analysis. And we'd say, well, what's it mean? You know, your analysis, you should be producing this, then starting your analysis. What does it actually mean? So in terms of using it for intelligence-led operations, this is an example of comparing collision hotspots or clustering with the deployment of booze buses. Again, some points I put on here, so I don't think you can avoid these on the way home. The colour there is supposed to represent how many people they're detecting drink driving. So green, what it means is, when we did the real ones, was green meant they weren't catching a lot of people. So if they were sending booze buses to this location again and again and again, because they have their favourite spots where it's easy to set up, you know, they go, oh, this is a good spot because we've got a lot of space, no one can see us until they come around the corner, it's a really good spot. But they're not actually preventing collisions there, they're not catching drink drivers. So for quite a few years they would just run it in that way, you know, where should we put our bus? And someone would say here, versus being able to actually look at the data and say, where should we put it? So if they put it somewhere like this collision hotspot up here or near this one, the idea is that people will see police and maybe behave a little bit better as they're driving. Geocoding. So geocoding means matching a record to a known location. So our crime data, you saw the crime report before, they're not there recording the X and Y coordinates or the longitude and latitude going, oh, where am I? I'm at this longitude and latitude. So what they're doing is recording an address. An address is okay, but where it gets quite hard is when they're recording just locations. So like, you know, Royal Park is actually about as big as some suburbs. Or if they just record, say, Bourke Street, Melbourne. Bourke Street's, you know, about a kilometre long, so it's about where do you put that point on the map. Country addresses aren't very good, so there's a lot of houses which don't sort of have a formal address. So when a crime or a burglary or something happens there, it can be hard to actually say, well, what's the address here? And the farmer says, I don't know. And yeah, typically when we're looking at this, so it can take a long time to geocode that data, trying to match it to known address points. And you sort of think, no worries, I'll match 30 Smith Street with 30 Smith Street. But there's a lot there which doesn't match. What we try and hit is about 85% to be put on the map. Then there's some research which sort of looked at putting 100% of data on the map, running some sort of statistical output, and then removing points one at a time, and looked at what point does the result differ significantly from the actual result. And they found it was about 85%. So once you're below 85%, you might not be looking at the real picture of what's going on. That's another example of, so that's from the bushfires, of houses destroyed during the Black Saturday bushfires. They were matched to the address point, which is generally, it's either where the water meter is or it's the driveway or something. What those arrows are showing is the distance to the actual house for that location. So this was one that caused a bit of issue where they were saying this is where the houses got burnt, and they weren't. They were just the address points, which is just a point at the front of the property. Another little issue is how to map in-transit offences. So say offences occurring on a train. So here's an example is someone gets on a train at Richmond, gets off at Camberwell, realises that their iPad's gone. So it's like, okay, they go and report it, and they don't know exactly where it occurred though. So it's stolen at some point between there. So the way it's recorded is in transit between Richmond and Camberwell station. When it comes to mapping that crime, it's about where do you put the point? Where do you say that crime actually occurred? So one little trick we came up with was this one, in transit between Newmarket and Moonee Ponds Railway Station. 2 sections of track there, so 2 stations apart. So we say 50% probability or 0.5 will add to each one of those sections, and we do that for all the crimes then, and come up with something like that where it's sort of where there's uncertainty, it's spreading it out along the track, so you're not skewing it to the from station or the to station, and not that useful if you're just looking at a week's worth of data, but when you're looking at, say, a year's worth, you do start to see those trends. And again, don't get too worried if you live on this line or this line. It's just fake data I came up with. A way of visualising that for the bosses to see which areas they should deploy their resources. I'm not going to read through all this, but we came up with a way of estimating population distribution based on address points. So you can get population that it's normally at quite a large area, so say postcode or something like that. If you need to go down further, like we do when we look at our crime data, we want to be able to say there's actually, within that postcode, they all live on this side, or they all live at the northern end, or something like that. So I came up with a way of estimating that. So that's what you could get from the census data. And you can see this, so say like down near Werribee, this whole area here is actually quite a large area, and I can tell you that there's not people spread out through that whole area of Werribee, they're all sort of concentrated in this one area. So using the address points to indicate where people actually live within those areas. Let's just go down to a much finer area of detail. I think these are 500 metre grid cells where we can estimate quite well how many people live in there and start to look at crime rates per population. Okay. I showed you before some hotspot techniques. What they generally do is just look at where is there more crime, where is it clustering. And that was used for a long time. So because there's the statistics course, I thought I'd better throw in some stats up. So there's other ways of looking at it. The question was debated a lot over the years of when is a hotspot hot, right? So when is it actual hotspot? So, you know, out in the country, 5 crimes might be a hotspot. In the CBD, 5 crimes happens, you know, quite a lot. The way this statistically significant clustering routines work, and this is how I try and explain it to police, so it's quite simple. If you had, say, 100 marbles and drop them, and 4 of them cluster here, you know, is that a hotspot? And most people say, nah, is it a hotspot? Are they clustered there, or did they just happen to fall there? People say, oh, could you happen to fall there? You know, look at the whole pattern. So I did a random number generator here to create these. They say, no, they're not. And they say, what about if 50 clustered here? Is that a hotspot? And they go, yeah, it is a hotspot there. That wouldn't happen by chance. So, like we were teaching last time, it could happen by chance, but it's so unlikely that you apply a test and it says it's so unlikely to happen by chance that, you know, you say, no, it definitely is clustering because of a reason there. And then it's about, well, what's your cutoff for what's a hotspot or not? 4's okay, 50's not, and, you know, what about 5 or 10 or 20? So rather than you having to make that decision and go, oh, 15 maybe, it's a statistic that will help you make that decision.
Sorry, Pete.
Yeah.
Can you just go back to that slide?
Yep.
I just want to add, this is probably a very good demonstration of what we mean by null hypotheses and the actual sample that you gather, right? So if you go back to the, this is your null hypothesis, the assumption of no significant clustering. That is your null. And the observation is the other one where you have a whole bunch of marbles right here in the middle. So the comparison between what you observe and what you assume is the process of hypothesis testing. And essentially that's what the team was doing.
Yeah.
Thank you.
That's all right. So the actual statistic is called GI star, and it's used in hotspots a lot. You know, it's my job sort of training people how to interpret it, what it is, and I'm probably going to be doing that for the next 10 years or something. But this is an example of randomly generated points running a normal hotspot technique over it, and what it's doing is saying there's more here and less here, right? So it's sort of saying, in terms of this area, this area has the most, this area has the least, versus this one, which is doing the test. So this one actually comes out only one area where it says this could be significant, but it is actually testing the rest of it and saying, based on how many points you've got in that size area, I'm essentially finding a random scattering, so there's no clustering there. Another project I've been working on is forecasting road trauma. So this was after I did some studies at uni and then got tasked with coming up with something for road trauma. So predicting the number first, which takes into account a lot of seasonality. So we see the same sort of things happening at the same time of year each year. So obviously in summer months it's warmer, more people out drinking, things like that. Winter, everyone stays home and watches MasterChef or something. So you have that allows you to forecast it quite well. So we get the number of expected collisions, and then within each sort of police division distribute them using something called risk terrain modelling, which I'll talk about soon, where we look at different variables. So that's an example of a retrospective one where I've tried to forecast the number of collisions for this area, which are the sort of yellow and green colours here. The purple dots are then the collisions which actually occurred, and it's forecasted 46 and there was 44. So it does a pretty good job of saying what do we expect, and a lot of that's because it is quite predictable. People travel down the same roads, the same type of volume every day, and you can start to see those patterns. And they can also get an adjusted count where it adjusts it for the volume of traffic there as well. Geographic profiling, just keep in mind you've got to go. So it's examines the geography of a crime series. And what we generally look at is which locations are chosen. If you assume that they're not chosen at random, which is almost impossible, most people know an area and they're choosing their locations of whatever they do. And criminals choose their crime locations as well. And also look at which areas are they not choosing and try and think of why. There's some software that does it, comes up with these nice pretty maps, and the basic premise behind it is this, distance decay. So this is where the person lives, and it's saying less likely to commit crimes right next door to them. Or less likely to go rob your local milk bar because later on you'll go there to buy an ice cream and they'll recognise you. So they won't commit as many crimes right next to their house or their location, but at the same time, someone's not going to travel 200 kilometres to rob a milk bar and drive all the way back. They'll spend more in petrol than they'd get from the milk bar. So there's a maximum distance as well, or a maximum that they'll travel. And what you end up is this peak distance where it's not too close, not too far, is what come up with. So if you take that and assume that for all their crimes they've applied that, you can work backwards and say, I'm assuming they haven't travelled too close, too far for each one of these crimes, which areas are the most likely, which is where these colours come in.
So, sorry, Tim.
Yep.
So this little curve here,
yep.
You estimated the shape of this curve, based on the criminals that you have caught.
You can do that. So you can look at your own criminals and look at all their offending behaviour and come up with a peak distance. Or the software can estimate it for you where they've based it on their studies.
Right.
So it's sort of pioneered by a detective in the US that looked at a lot of criminals. Yep.
And what is that peak?
Why? Yeah. I think it varies, but so like we had a master's student do it for sex offences, and I think it was about 2 kilometres.
So, and this is very important. The reason why I'm saying that is because later on I'm going to show you a little website on crime mapping in the US. And in the US there is a law that if there is known sex offenders, they have to report the address of that person in. So this becomes important because if you knew what this peak distance is like, you would try not to buy a house within that distance to that guy. And but in Australia, I don't think there is such a law. But
no, it's not
in the US,
public. Yeah,
they actually publish the photo of that person and know the demographics about that person. So it's pretty detailed stuff.
Yeah.
But obviously it's different.
And it is scary. Okay. So that's what the software can do, but I find it's more about the analysis, so the looking into each thing, and it's not always about, this software can be quite expensive, but it's quite basic in what it does, so I'm never going to recommend they pay all that money for it. Here's an example of one similar to something that we looked at. Coming up, the house at the top, we'll say it had its letterbox blown up by a, like a firecracker or something like that. And when I had a look at the road layout, to get to that house, you have to travel up this road here, across here. So thinking about it, if someone's going to go up there, blow up this person's letterbox, get out, are they really going to want to travel all that distance to get out of there down to that main road? I just had a look on what's called Google Street View. Next to it's this sort of parkland area. It's actually a school. Much easier to access that house this way. Now, if they're accessing the house that way, like I said, it's across parkland. They're not going to drive across there, so they're going to be on foot. And if they're on foot, they're going to probably live closer to that area. So when we're looking at these, which was actually a series that spanned a really big area, this is the sort of clue that said, I'd be looking in this area. And they did. They lived just sort of across a little bit. Continued geographic reference. Like I said, the software is quite expensive. It does things like this, a 3D model of that surface. So when it's a flat surface, they call it a geoprofile, and when it's 3D, it's called a Jeopardy surface. And this doesn't help you in any way to do your profiling. So there's a lot of stuff, a lot of hype about what it can do, but you really have to understand it and look at it. The other thing is it considers two types of offenders. One's called a marauder, lives amongst their crimes, heads out from their base, which is normally their house, but it could be something else, like their work location. And then there's commuter, where they travel somewhere to commit the crime. So these software only work with that marauder one, that can only work within the area. What we see, though, is a lot of commuter crimes. Mostly they'll head towards the city, more population, more opportunity and things. And there's always debates going on, like international debates and fights and stuff about how you measure the accuracy and just comparing it with the centroid. So if you took these 5 crimes here and looked at what's the centre of those points, often that will be quite close to the offender's location as well. I think this is my last slide. Predictive mapping. There's a few different versions. So there's something called prospective hotspotting, which considers that crime's like a disease. So a house gets burgled, the houses around it are at higher risk, up to a certain distance and for a certain amount of time. So basically, if a burglar goes to an area and targets that area for a little while, it means that area is more at risk. This mapping process takes that into account and says, based on the fact that you've had these crimes, the areas around it are more at risk, they're the most likely areas. Rather than just looking at the past crimes, where has the crime happened? There's another program which got media attention earlier this year. If you look up Numbers Men of LA, you'll find a lot of articles on it, called Predpol. I think part of the reason why this one's so popular is it uses an earthquake metaphor. So it considers that there's crimes and then there's aftershocks, and it tries to model those. I think this one's quite popular because LAPD are using it. So, and the other thing is that it uses Google Maps, so it's really easy to use for the police there. But they measure their results based on the crime statistics in those areas. They're sending the police there, though. So, you're sending a lot of police there and then measuring the crime and saying, oh, look, it's gone down. But, if they sent them to other areas, the crime would probably go down there as well. The other thing is not all crimes have aftershocks. So they limit it to burglary and gang-related shootings, which we don't really have a problem with in Melbourne, hopefully. So not as useful for us. And the last one's risk terrain modelling, where it considers the presence or absence of risk factors. And those factors can be static or dynamic. So you can have things like railway stations, railway lines, and things that aren't likely to change over the year. They don't disappear and come back. But then you've got dynamic variables such as someone gets released from jail and goes to live in a house. So you can put those as a risk factor, for example. And there's some good papers on risk terrain modelling where they test those factors for significance and pick the most significant factors and find that they get a better model in the end. Again, looking at shootings and things like that. So what it does is it maps all the different risk factors, adds them up, comes up with a final score that says here you've got 5 of the risk factors, here you've got 3, here you've got 1, and you get an output map which says this area is more at risk, this area is less at risk, and so there's varying results with that. There's my contact details, and I'm happy for questions.
Any questions from the students?
It's 4:30. So. No, well, there's my contact details, so feel free to contact me if you've got any questions.
All right.
Just going to take it home.
Okay. All right. Thanks, Tim. Thanks, Craig. So these are the